Very warm welcome to one and all. A very good afternoon to all our guests joining in from the UK. A good evening to all our guests joining in from India and Southeast Asia. And a very good morning to all our guests joining in from the US and South Americas. Today is the fifth seminar in this second edition of this seminar series on the digital future for business and society, emerging perspectives on AI, blockchain, and IoT. This seminar series has been hosted jointly by Professor Yogesh Dwivedi, who is a professor of digital marketing and innovation, founding director of the Emerging Markets Research Center, and co-director of research, School of Management, Swansea University, Wales, UK. Our co-host for this seminar series is Professor Raman, Director SIBM Pune, Dean Faculty of Management, Symbiosis International Deemed University, and Director Strategy and Development, Symbiosis. Our entire seminar series is jointly supported by the Center for Technology, Innovation, Management and Enterprise, the University of Kent, UK, Digital Marketing and Analytics SIG, Academy of Marketing, Grenoble IAE Graduate School of Management, a Grenoble INP School of the University of Grenoble Alps, the E-Business and E-Government SIG, British Academy of Management, and the UK Academy for Information Systems. To tell you something about the seminar series itself, emerging technologies such as artificial intelligence, blockchain, and Internet of Things undoubtedly offer a transformative potential for the augmentation and the potential replacement of human tasks and activities within a wide range of industrial, intellectual, and social applications. The pace of change for this new AI technological age is staggering, with new breakthroughs in algorithmic machine learning and autonomous decision making, coupled with developments related to blockchain and IoT, engendering new opportunities for continued innovation. The impact of AI and other emerging technologies could be significant, with industries and sectors ranging from agriculture, finance, healthcare, manufacturing, retail, supply chain, logistics, and utilities, all potentially being disrupted by the onset of these technologies. The seminar series on the digital future for business and society, emerging perspectives on AI, blockchain, and IoT will present various perspectives from a number of leading expert speakers to highlight the opportunities and challenges posed by the rapid emergence of these transformative technologies. Today, we have with us one such expert speaker from the area of location-based services and IoT, Dr. Roba Abbas, who is from the School of Business, University of Wollongong, Australia. Dr. Roba Abbas is an academic program director and a lecturer with the Faculty of Business and Law at the University of Wollongong, Australia. She has a PhD in location-based services regulation and has received competitive grants for research addressing global challenges in areas related to co-design and socio-technical systems, operations related to co-design and socio-technical systems, operations management, robotics, social media, and other emerging technologies. Her current research interests include methodological approaches to complex socio-technical systems design. More recently, she has delivered talks and co-organized panels for Yale University, the Alan Turing Institute, the American Association for the Advancement of Science, Arizona State University, and Australia University of Applied Sciences. Dr. Abbas is the co-editor of the IEEE Transactions on Technology in Society and was the technical program chair for the IEEE International Symposium on Technology and Society, hosted by the Arizona State University in November 2020. From 2005 to 2010, she was a product manager with Internet Tricks at Wollongong. Dr. Abbas, over to you.
Thank you so much. Good evening, everyone. Thank you, Dr. Santosh, for the introduction, and thank you to Professor Dwivedi and Professor Raman for the invitation to speak in this seminar series. I'm delighted to be here sharing the outcomes of several research projects and my thoughts on socio-technical futures, specifically within the context of location services, the Internet of Things, and the future of work. I've taken the liberty here to extend my focus beyond the future of work to the future in general, to our future. Before I begin, I would like to give an acknowledgement of country, which is a practice we perform in Australia in recognition and respect of the Aboriginal people and their ongoing connection to land. I'm joining you this evening from Wollongong, Australia, and as such, I would like to begin by acknowledging the traditional custodians of Dharawal country and pay my respects to the elders past and present. I would also like to acknowledge and introduce some of my collaborators on this work, namely my long-term collaborator, Professor Katina Michael, with expertise in information technology, engineering and law, currently at Arizona State University, Associate Professor MG Michael, specialising in philosophy, theology and history, formerly at the University of Wollongong, Associate Professor Rob Nichols from the University of New South Wales, Australia, with expertise in regulation, technology and engineering, and Professor Jeremy Pitt from Imperial College London, with a background and wealth of experience in engineering, specifically intelligent and self-organising systems and artificial intelligence. And that brings me to the seminar itself. And I'd like to start by disclosing the last slide in my talk, which is a representation of how we envisage the role of information systems and technology as related to our digital future. And we could potentially leave out the word digital here and replace it with socio-technical future, or simply our future. So historically speaking, if we are to address the question regarding the future role, the implications and the impact of technology from the perspective of the information systems discipline, our response and our perspective on systems and technology would largely depend on the period we are referencing. Currently, there appear to be two dominant and competing visions or perspectives. The first is techno-optimism, the idea that technology will primarily deliver benefits and positive outcomes contributing to a bright future. This approach can be quite technologically deterministic in its orientation without due consideration for the social implications and consequences, given that emphasis on harnessing technological potential. The second is techno-pessimism, which is the other extreme, characterized by a dystopian view of technology. This view is unfavorable due to a number of factors, for example, loss of jobs, among others, and perceives a digital future as somewhat bleak and destructive. I note here that the use of the anthropomorphic robot is for demonstrative purposes only, rather than to advance a particular view about humanoid robots and their future. The third perspective that I'm advocating for in this talk, which is a redefinition of the socio-technical perspective that is built on the basis of socio-technical systems theory, but extended to apply to present-day information systems and innovations. So this perspective is characterized by a balanced approach to the design of information and other socio-technical systems, and has a range of features that we have defined within a public interest technology framework as a research group. I propose here two key features or elements in particular that are required in order to work towards that middle ground or balance between techno-optimism and techno-pessimism. The first is a multi-tiered regulatory framework, and the second is a novel socio-technical co-design approach oriented towards a public interest technology agenda. And for the remainder of my talk, I will be working my way back and trying to explain how we have established these two frameworks or methodologies in multiple research projects concerning location services, the Internet of Things, and future of work applications, and how they can be applied to the investigation and design of other socio-technical systems. And my roadmap is as follows. I'll start off by defining the key terms to frame our discussion, moving on to present an overview of the research projects that we have derived our frameworks from. Given that I'll be covering a considerable period spanning over 15 years, I've separated the discussion into two streams, one of which is the future mode of operation, resulting in the development of a regulatory framework for advanced location services. And the second is a future mode of operation that builds on the outcomes in the context of the Internet of Things and Internet of Things-based platforms. And once we have progressed through these modes, I'll circle back to next steps and propose a definition of socio-technical co-design and what this means in terms of the future of work and our future. I'll start off with some definitions. Location services, which are also known as location-based services or LBS, have been defined in numerous ways in the literature. As part of our research, we have adapted several prominent definitions to define location-based services as the applications that combine the location or position of a mobile device associated with a given entity, and this can be an individual or an object, together with contextual information to offer a value-added service to the end user. In this instance, the end user could potentially be a consumer, business, or government entity as per traditional electronic business, electronic commerce, and mobile commerce models. Location-based services may also or alternatively be employed to fulfill a particular need for the user, and this is facilitated over a wireless network. The highlighted text on this slide are important in that they allow us to unpack the main features of location services. And there are seminal studies that point to these features. For example, an important consideration with location services and the value-added component that I mentioned on the previous slide, according to work led by Professor George Giaglis, is that LBS are not solely based on knowledge of an entity's location, although that is important, but rather they rely on the coupling of location information with further data of interest to the user. Other features of location services are derived from their mobile commerce or location commerce origins and the complex value chains or networks that are required in delivering a given LBS solution. So these features and intricacies have been documented in foundational works by Professor Roger Clark, Marcus Wigan, Axel Cooper, Michael and others. And for the purpose of this discussion, an appreciation of the diverse operational and non-operational stakeholders involved in supporting consumer, business, and government applications is important. Stakeholders include those that are operational, so stakeholders such as content providers, application and portal providers, wireless network operators, positioning and location technology vendors, handset and device vendors, and others that would sit in a supportive capacity. There are also non-operational stakeholders, and they include government entities, standardization bodies, committees, and research bodies, including research and development and academia, and of course, not forgetting the end user. What's important to note here is that a single stakeholder in this value chain is unable to provide an application to the end user. Rather, we require partnership and complex interactions. In the interest of time, I'll briefly flag, without explaining in great detail, that location-based services can be categorized in numerous ways. So they can be referred to as push versus pull services, those that are reactive versus proactive, and in terms of a taxonomy of application areas. So examples in this instance would include emergency management-based LBS solutions, navigation, advertising, tracking, and other services. And they can also be categorized in terms or classified in terms of their value-based classifications, which are then mapped to specific applications or categories of location-based services. But irrespective of the location-based solution or categorization, the common features are mobility, so that's the ability to alter location, personalization, the ability to tailor a service to meet or accommodate individual requirements, and ubiquity, so from a mobile commerce perspective, that's the ability to be accessed anywhere, anytime, and across a range of devices. The second concept that I'd like to define is the Internet of Things, or IoT, which many of you will have come across in its various forms, including the Internet of Everything and the Internet of Things and People, which are often used interchangeably, but sometimes they are also expressed in terms of their distinguishing features or aspects. And although numerous definitions exist, the IoT is generally defined as either things or objects connected to the Internet, and or things or objects connected and communicating with each other in a machine-to-machine kind of fashion. The term itself was coined by Kevin Ashton in 1999 in reference to the ability to empower computers in the process of gathering information, as opposed to solely relying on humans for that same task. Ashton revisited his definition and clarified his definition after about a decade in the RFID journal, with an emphasis on computers knowing, tracking, and counting everything utilizing sensors to enable positive outcomes. So these could include things such as waste and cost reduction and overcoming restrictions associated with human information gathering, amongst other outcomes. And I'll return to the link between the Internet of Things and location-based services further in my presentation. Now that the background has been established, I'd like to share this timeline that succinctly represents the work we've conducted exploring the various facets of location services, the Internet of Things, and the future of work. And this is in a very diluted and aggregated form. We commenced work as a team around 2005 in the areas of cybersecurity, risk management, information systems, and emerging technologies, looking specifically at national security. And we did this from the perspective of studying the impact of public sector information on critical infrastructure protection. I was simultaneously working in industry in an e-business company at the time, but as a group, we were committed to the study of the implications of emerging technologies and socio-technical systems since this point in time. Our work in 2005 and 2006 formed a solid foundation for studying the need for location-based services regulation in Australia. And this was part of a grant funded by the Australian Research Council and led by Professor Katina Michael. As part of this work, we commenced roughly between 2008, 2009, we commenced our project and engaged in a consultative socio-technical research investigation, where we built on this investigation in subsequent projects since to explore the intersection of technology, society, ethics, and regulation. The ensuing projects that can be seen between 2010 and now include, for example, research relating to location-based social networking, location-based artificial intelligence, big geospatial data, location analytics, contact tracing and tracking applications in the context of the COVID-19 pandemic. And currently we have an emphasis on transdisciplinarity to promote an awareness of the regulatory frameworks and the value of co-design approaches when we are considering the socio-technical design of systems, both those systems that are location enabled and otherwise. So for the purpose of scoping this presentation, I'll be discussing outcomes, as I mentioned earlier, across two modes of operation, which I've color-coded on the slides, the present mode in blue and the future mode, which is represented in gray. What we now consider the present mode of operation essentially encompasses the outcomes of our work conducted between 2009 and 2020, with a focus on the more traditional, in inverted commas, location-based services that conform to that earlier definition that I mentioned or provided earlier. Example applications include emergency management, navigation, child monitoring solutions, and others, which are often termed advanced location-based services. Our research was predominantly focused on establishing whether there was the need to regulate the location-based services industry in Australia. The initial challenge we faced or we were faced with had a number of dimensions to it. So the first was that location-based services were being designed, developed, and implemented without due consideration of the associated socio-ethical and regulatory implications. The second dimension was that the focus in the engineering and information systems domains and in industry in general was on exploiting technological potential rather than on any direct focus on the social aspects or on the people. And thirdly, there was a lack of academic scholarship concerning the need to regulate the design, development, and deployment of location-based services in Australia. And we were specifically looking to do a number of things. The first was to assess the usability of location-based services in Australia. The second was to evaluate location-based services value chains in terms of the relationships and dynamics between stakeholders. Thirdly, we were trying to examine and present the socio-ethical dilemmas, both spatially and using other means. And lastly, we were attempting to review existing legislation and regulatory provisions. In summary, in terms of the outcomes, which I've summarized on the screen, we presented a solution in the form of an aggregated multi-phase socio-technical design methodology for stakeholder consultation that had application beyond and has application beyond the LBS context. And secondly, we presented a complementary component of the solution, which was a regulatory framework, which we termed a regulatory pyramid, created in consultation with consumer, industry, and government stakeholders. And again, that can be employed in the context of other emerging technologies and systems, not restricted solely to location services. The current slide that I have here presents the stages involved in addressing that challenge and reaching the proposed solution, from the theoretical underpinnings through to the methodology and the previously stated outcomes. And if we were to start to the left of the slide, we designed the research on the foundations of an open systems paradigm, employing a derivative in socio-technical systems theory, which emerged from the Tavistock Institute in London in the 50s. This was employed as the theoretical lens for our study based on seminal works of Trist, Emre, Bostrom and Heenan, and Mumford, to connect the existing industry and government processes that were in existence. The socio-technical approach that we employed was supplemented with concepts and practical elements from social informatics, from public policy processes, and also in recognition of the existing regulatory environment. And this adapted socio-technical view enabled the location-based services value chain to be conceptualized in terms of the constituent social and technical components, which are referred to, as per the theory, as subsystems, and they are embedded, those socio-technical components, within a broader environmental subsystem. This provided us with a comprehensive and complex view of what we call the LBS ensemble, and it allowed us to engage in the study of location commerce applications as a subset of e-business, e-commerce, and mobile commerce in context, and also with the appreciation of the embeddedness of these advanced location-based services. Specifically, we adopted a socio-technical consultative approach, which was comprised of 3 distinct but interrelated phases that would allow us to propose a solution to the identified challenge. These phases can be seen in the funnel on your slide. And phase 1 was centered on the observational study of users, phase 2 on interviewing operational and non-operational industry stakeholders, and phase 3 on engaging privacy and emergency-related government agencies in regulatory discussions. Our research results derived from the stakeholder consultation indicated that location-based services regulation in Australia is in fact necessary, and that a multi-tiered framework is required. And I'll be presenting that framework in a moment. But before I do that, I'd like to provide some visibility on what the phases looked like. And here are some example images. In the interest of time, just checking the time there, I'll provide a brief overview of each of the phases. So phase 1 was the observational study, which involved the collection of observational data over a 2-week period in the form of GPS data logs, which were collected using handheld and in-vehicle data logging devices in addition to smartphones. And we collected qualitative reflections to supplement these in the form of diary entries. And these entries were analysed thematically, and the data logs were analysed spatially using a geographic information system accompanied by a range of obfuscation and computation techniques, as demonstrated graphically on the slide. The spatial analysis was key in this process because it was converted into a discussion paper containing storyboards and scenarios across a risk spectrum from low to catastrophic risk levels. And the discussion paper itself was used to inform our second and third phases of the study. The second phase was centered on conducting semi-structured interviews with operational and non-operational stakeholders, where we sought representation for each industry stakeholder type in the location-based services value chain. And we did so in order to gauge perspectives on a number of things. The first was the extent of the organization's involvement and in location-based services and what they anticipate to be the future trends. Secondly, we asked about the benefits and concerns of LBS usage, including mechanisms to increase the benefits and other mechanisms that could be used to reduce or mitigate some of the concerns that they had. We also spent quite some time focusing on location information itself. So location storage, usage, method of managing access to location, and so on. And finally, the discussions were steered towards policies and regulations, so the existing situation and future requirements, and these results were analysed thematically. In terms of the final phase, this was a formalised process of engagement with government agencies through official requests for statement and consultation as per the appropriate means of engagement with federal and state government agencies here in Australia. We focused on government agencies that were relevant to the two extremes within our scenarios or our scenario categories, and they were the emergency management agencies and those that were related to privacy or the privacy-related entities. On the basis of the three phases, we were able to determine competing perspectives regarding location-based services in general and the need for regulation more specifically. On the current slide and the following slide, I'll be presenting some of the common themes emerging from regulatory discussions to form the basis for our regulatory framework. So for example, if we were to look at users and user perspectives on regulation, users were very much focused on achieving a balance between the desirable and less desirable uses of location-based services based on the outcomes of our usability study. They also flagged the importance of ensuring vulnerable individuals were adequately protected across a range of usability scenarios, and regulating specific instances of use was also a dominant theme in this stakeholder category. From the perspective of the industry or industry stakeholders, there was a reported need for regulation through a consistent framework across Australia, which was not in existence at the time, rather than a somewhat patchy framework that was differing or that differed between respective states. Other central themes included amending existing legislation and focusing on co-regulation and other mechanisms such as codes, standards, and industry-based principles. Some of these themes were reinforced when we came to the government stakeholder category, with additional insights that were reported on specific to regulating LBS in emergency scenarios. And I've provided a number of representative studies for anyone interested in the outcomes in greater detail. With respect to advancing stakeholder interests and focusing on one of those two elements that I mentioned earlier to achieve our middle ground, we incorporated multiple and competing stakeholder views and examined the distinct perspectives on the previous slides, and that resulted in the development of the proposed location-based services regulatory framework for the Australian context, which we suspect will have a broader application to other contexts. The regulatory pyramid is comprised of desired multiple approaches to regulation, each of which corresponds to a specific type of stakeholder. So for example, user, industry or government stakeholders. And as we work our way up, we go from the work our way down, we go from the micro or individual perspective at the tip of the pyramid through to the macro social perspective towards the base. And this pyramid shows that the specific social, technical and environmental aspects that are required in respective regulatory approaches must be connected to usability, service provisioning, technological development and legal protections. Starting at the base of the pyramid and working towards the apex, the individual approaches to regulation themselves, so those central areas or items in the pyramid, need to be built upon one another. So this tiered approach promises multiple levels of regulation with the purpose of safeguarding and accounting for multiple and competing stakeholder interests. And what is reinforced here, based on our research, is that one approach to regulation is insufficient given the diverse challenges and use cases. Rather, we require a combination of legislation, technical guidelines, standards or embedded mechanisms, internal policies and codes, and also ethical and moral codes when we're speaking of either location services or emerging technologies that exhibit some similar concerns. I'll move on from the present mode and discuss a bit about where we're currently headed in extending our theoretical and methodological approaches in light of the regulatory and other outcomes from the previous decade or so of LBS projects. So we're currently shifting from the socio-technical design and regulation of advanced location-based services to IoT-based platforms and the design of socio-technical systems in the public interest. In providing additional background to this shift and understanding the relationship between location-based services and IoT, we can think of location services or regard them as vital for the growth of the Internet of Things, moving beyond what we consider advanced location services to increasingly more connected, or an increasingly more connected perspective, whereby everything or object can potentially be monitored, tracked, localized, and controlled through the use of location sensors that would supplement numerous other sensors that exist within the broader IoT infrastructure. Additionally, the locational spatial element enables the coalescing of the physical and the digital worlds, effectively forming a bridge between the two, as well as the seamless movement, or allowing for the seamless movement and routing between indoor and outdoor environments. This brings with it a whole host of opportunities from the perspective of patient health monitoring, sustainable smart cities with the potential, for example, to enhance existing infrastructure, resource provisioning, and more, in addition to analytics capabilities that will benefit retail, business, and a range of other operations. One such example that our team is exploring at the moment, or one such research project, is the design of a location-enabled platform, for example, an underlying information system that would facilitate the safety and freedom of individuals living with dementia and other neurocognitive conditions. And if anyone is interested, I'd be happy to point to more information about that project. So despite some of these opportunities that I've identified here, there are a range of socio-ethical challenges relating predominantly to issues of control and trust, which are beyond the scope of this presentation, but we have reported on these socio-ethical considerations in a paper referenced on the screen for anyone who's interested. And we presented this in the form of a socio-ethical impact framework relevant to location services and the Internet of Things. But beyond the original socio-ethical impact analysis, when we consider the socio-technical design of future location-enabled platforms, the challenges are somewhat consistent with our prior research and the previously listed challenges. That is, socio-ethical and regulatory considerations are not always factored into the discussion, and human-centered elements and values are typically not at the forefront of design and development discussions. What we are proposing in our current work and as a solution is the socio-technical co-design of platforms that embed values and also reconcile competing interests in the underlying design of information and other systems, again with those corresponding regulatory frameworks that I mentioned earlier. The proposed solution is the product of, I think, a natural maturing of the research projects that we've been involved in over time, where we've come to an awareness regarding the limitations of existing theories and approaches to complex socio-technical systems design. We feel we're somewhat closer to a suitable vocabulary that will allow us to articulate ways in which we can contribute to overcoming some of the existing limitations. Our major outcomes to date in terms of progressing our research in the future mode of operation include that recognition that we are working within both present and future modes simultaneously, and may as a result be engaging in parallel and not necessarily consistent design processes. Another outcome is that the consultative approach we employed and that I mentioned earlier and that we validated for the present mode of operation must be adjusted when we are transitioning to this future mode where there are IoT-based platforms and models. From the perspective of redefining the means of engagement and also in terms of knowing how best to configure our design process, another fundamental outcome and contribution is in the notion, which I will present in a moment, of socio-technical co-design, which I will also provide a definition of. We believe that socio-technical co-design is a promising approach for future modes of operation and for future of work scenarios that involve location services and the Internet of Things. One other observation that I would like to point to is that future modes of operation necessitate that we move beyond certain things. These things include moving beyond multidisciplinary approaches into those that are transdisciplinary in nature, moving beyond socio-technical consultation or design methodologies to design partnerships, that is co-design as our appropriate target. We also need to develop beyond mobile and location commerce-based conceptualizations to a more complex socio-technical ensemble view within which your location-based models and mobile commerce-based models are embedded. And a final note is that static regulatory models need to be transitioned to those that are multi-tiered and have scope for development at a pace that is closer to that of technological developments. And I do recognize that this is quite an ambitious statement. In terms of reframing now our challenge, these outcomes that I've highlighted require the reframing of a challenge in the previously presented approach, which I've essentially summarized on this slide and flagged the required changes in red. As you may know, we have integrated the regulatory pyramid to supplement our theoretical underpinnings, and that was not there before. We've also extended our focus beyond the mobile commerce and location commerce models and domains to a more platform-based view, one that recognises that the stakeholder set will need to be updated accordingly. And finally, we propose a refinement in methodology towards the socio-technical co-design approach. I'll just check timing. I might spend another 10 minutes if that's okay. Before I share further information about the socio-technical co-design approach and how we actually define it and our proposed definition, I'd like to note that both the regulatory framework that I shared previously and the socio-technical design concept that I will share in a moment are encompassed within a broader public interest technology ecosystem. And we've proposed the model, which can be seen on the slide, as a means of tracking the flow or process from the technological landscape that we exist within, right through to the design and development of technology that serves the public interest. In this presentation, I've only presented a partial view relevant to location services, the Internet of Things and the future of work, but this diagram offers a more comprehensive representation of how this would look in a real world context and also in a form that can be generalized and adopted for other emerging technologies. In the interest of time, I'll start wrapping up the discussion by returning to what I consider the balanced and measured lens through which information systems and technology could be viewed, somewhere between that techno-optimism and techno-pessimism perspective. In terms of future research, our work seeks to emphasize the importance of pausing in the process of systems design to factor in the regulatory landscape, both the current and emerging. We also hope to champion the concept of socio-technical co-design, which we recognise requires a number of things, and these include extensions to socio-technical systems theory and existing theoretical approaches, the development of new means or techniques for operationalisation, and a shift from, as I mentioned earlier, multidisciplinarity towards transdisciplinary approaches, among other efforts. And I will end in the next few slides with our definition of socio-technical design, but just to provide a bit of context, there's scant literature available on socio-technical co-design as a concept, and existing studies largely reference those two terms, so the socio-technical and the co-design, as distinct terms. However, we believe here that there is the potential to amalgamate these terms in a way that will allow us to inherit theoretical and methodological assumptions that will be valuable for operationalizing socio-technical theory in a way that will bridge the gap between academia, specifically the information systems domain, industry and practice, government, and users or members of the public. As such, we propose the definition here that I'll briefly unpack on the following slide. And that definition is that socio-technical co-design socio-technical co-design needs to consider a number of things and can be conceptualized and proposed in this way. It is about the involvement of end users, and this is quite a long sentence, so bear with me, involvement of end users and stakeholders with a legitimate interest in a socio-technical system in its conceptualization, its design, and development through the establishment of a balanced design engagement with the purpose of addressing a jointly defined problem or challenge and embedding identified values in order to achieve a state of equilibrium towards stakeholder empowerment. This definition embodies a range of concepts which are color-coded on your screen. The first is the importance of a human-centered approach to design when we are referencing the involvement of end users and other stakeholders. Next is the notion of balance in a design partnership that is void of any power asymmetry. A third is a problem or challenge, or having a problem or challenge presented as a systems goal and one that is collaboratively defined. The fourth point emphasizes the importance of ensuring and achieving or factoring in, the principles, ethics, and standards. Next, we have the emphasis on the importance of ensuring and achieving equilibrium or a steady system state as the product or a product of design. And lastly is the notion of stakeholder empowerment linked to ideas of design that promotes and works towards achieving human health, well-being, environmental sustainability, and also a responsible approach to the design of socio-technical systems that will inevitably impact on our future. And I think I'll leave that discussion here, spot on 40 minutes. Thank you.
Thank you, Dr. Roba. Thank you very much for first and foremost being bang on time, and that's a fading skill, and I'm sure you've reignited that once again. This is a very interesting topic and a very intriguing one as well. Before we get on with questions, participants, may I request you to please post your questions in the window. But before that, I would probably want to request your thoughts on how to maintain a fine balance between user benefits that a user would get by enabling location-based services versus the lack of it, which means what if he does not or she does not activate location-based services. So is there a trade-off from the service perspective that service providers can offer? For example, let's say mobile-based services.
That's a great question, Dr. Santosh. An interesting one that you use the term trade-off, and it's something that we've looked into in the past, and I'm going to spend a bit of time just talking about that concept. So I think the concept of a trade-off is a really interesting one in socio-technical design and systems design in general, because we tend to use trade-off terminology, which is quite prevalent in the operations space, and we know that's a thing that needs to be considered, and we always need to be trading off performance objectives and other objectives. So that's a given. In terms of trade-offs of using location-based services more specifically versus not, and whether there is a trade-off, perhaps you mean in terms of user privacy or trading something for a convenience, I think the trade-off terminology doesn't serve our purpose as well. I think there is a way in which we can design these technologies to achieve a positive sum, which means that we're not engaging in a zero-sum argument where we feel we need to trade something for receiving a particular service. There are approaches that are built on this or negating this trade-off assumption. If you've heard of privacy by design, that's one such approach, the work of Dr. Anne Kavukian, and that's moving away from the trade-off mentality towards one that provides us with this positive sum so we can access location-based services but maintain our privacy. I guess in terms of access in general, I guess there are scenarios where we can broaden this discussion and speak about, for instance, emergency management scenarios where we require access to location-based services, and there's obviously that balance between the provision of location details versus access to that service. But I think it's really context dependent, Dr. Santosh, in terms of considering that trade-off.
Thank you very much, Dr. Roba. We've got a question from Dr. Annabel Guterres, and she says, engaging on ethical discussion of use of technology for complex systems, do you have a specific methodology for the same?
Yes. So the methodology that I alluded to as part of my discussion earlier, socio-technical systems design, has an embedded notion of ethics and ethical alignment. Now, there are multiple approaches in existence. Sorry, was that Dr. Annabel? There are multiple approaches in existence, all of which are socio-technical in nature. So you have privacy by design, and security by design, democracy by design, and a range of other design approaches. The methodology we're specifically referring to here is about the configuration of the actual engagement itself. So what we try to do is conceptualize, in short, I'll be very brief, but conceptualize the system, what the system is, what the social, technical, and environmental components are. We define what is called this notion of optimization. So what does an optimal system look like? We engage with participants in that process in order to achieve that optimal state. And that part of that process is the ability to reconcile potentially competing stakeholder interests. But in short, in order to answer your question, we use the socio-technical design approach. We are hoping to extend that to that model that I presented on the last few slides, the socio-technical co-design approach, where we have high levels of user engagement. But within that, there is the, I guess, the potential to integrate other ethics-based approaches in the operationalization of the socio-technical approach.
Thank you. Thank you, Dr. Roba. Dr. Roba, there's another point that strikes me, which is there practical application of the theory that you just mentioned? So Are industries welcoming this, or how is the industry perspective? Do you think it is limiting for them, or it is more enabling? So, what are their thoughts? If you've been in touch with some of them during this process.
Yes, that's a fabulous question. I think it's a really important one. I guess a lot of this work, or the birth of a lot of this work, and particularly the socio-technical approach and our selection of that approach, was for that very reason, is that there's always this disparity, and that's well documented between, for instance, if we were to talk about the information systems domain in terms of the academic setting versus in practice or in industry, and there's quite a disconnect there. What was appealing about the socio-technical perspective was the ability to engage in existing systems design and development processes in a manner that we can supplement existing processes that are utilized in industry. So a lot of us in our team have that industry background. We have worked within those processes. We recognize the perspective as well of industry in terms of this being perhaps an inhibitor to technological progress, whereas we've attempted to show across a range of projects. So I presented a couple of projects. We have a range of other projects where we've demonstrated that planning and socio-technical design has benefits for all parties. So that's the underlying premise. In terms of industry perspectives on this, there was a clear distinction between maintaining that line of technological progression, so not inhibiting technological progress in any way, but they weren't necessarily opposed to any methods that would assist them in achieving their own goals. I think what's different and what differentiates what we're proposing here is is providing something that can be operationalized, and that's something that is missing. So often we might engage in socio-technical studies that are not practically applicable in industry, for example, whereas here we show the progression from what the actual technological landscape looks like, how we look at financing and business models. Again, for the purposes of this talk, I only covered a small subset of what this would look like, but you start off with the landscape, you go through to the business and financing models, then you engage with stakeholders, and that's a differentiator, which doesn't necessarily happen in existing systems design processes in industry, for example, or it does in some instances, but it's not commonplace. So our models are not conducive to that kind of approach. And then we go on to actually reconciling interests. So within this methodology that we're proposing, we acknowledge that there are competing and divergent stakeholder interests. In the basic philosophy is the ability to define a common goal, which is that joint goal problem definition that would serve all parties. And then once we actually determine interests and values and work within the context of a co-design partnership, as we are suggesting it, so that's a highly integrated partnership rather than treating the user as an observer, for example. The idea is then we can reconcile all of those interests, develop a solution that can then be applied in practice and tested and validated, and then we can iterate as we normally would. I might make one other point, Dr. Santosh, to that. What's really important is that we are not redeveloping a method of systems design. We are trying to supplement existing systems or software development or design processes with something that could work perhaps in a modular fashion. It is quite different to the traditional processes, but it's not intended to usurp or to replace those processes. And that could be the appeal from an industry perspective.
True. Thank you for that detailed explanation. And I think, as you rightly said, it's important that it should ideally have an industry acceptance, and that's very well visible with what you just mentioned. Nadine Goldthorpe has also put in a question, and she asks, systems are also designed to take advantage of opportunities, that is, as well in response to problems or challenges as per your slide. Those opportunities may benefit the designer more than the end user. How will you make sure you can apply the co-design approach in this scenario?
That's a fabulous, that's a great question. I'm just going to read the question again to cover all aspects in my response. Yeah. That's quite a common concern and a challenge and a limitation, I guess, of any design approaches, any systems design approaches where there is the capitalizing on technological potential and opportunities that could benefit the technologists, information systems professionals, and so on. I think what's really important here is that empowerment aspect. And that's what we are proposing. And with empowerment, there are a range of ways in which you can empower stakeholders. If we are to place them on, and particularly end users, if we were to place them on an equal footing, for example, as the designer, while also recognizing that the designer will facilitate that design process, I think that's a step in the right direction in terms of ensuring that there is no exploitation and that we're not working within the interests of one particular stakeholder category. In the operationalization of this approach that we are suggesting and that we are advocating for, and that is, it's important to note that it's built on previous socio-technical design work, so that concept does exist. We are proposing a slightly different flavor of that approach. We are endeavoring to engage in various, and I wish we had more time to sort of discuss this, various design configurations where you look at the stakeholder categories, the users, perhaps vulnerable or underrepresented, misrepresented communities, and then working with them to define the appropriate engagement strategy that will then lead to the representation of their values, their interests, to ensure that it's not driven solely by the technologist or by the designer, but exploitation and also these systems or these design endeavors being driven by a particular party is a challenge, a concern, and a limitation of this approach. Great question.
Thank you, Dr. Roba. So Katina Michael has posted a question on behalf of Jason Sargent, and he says, Roba, Jason Sargent here, thank you for the wonderful, concise overview. Would you and your research team suggest that empowerment is the critical way to overcome geoslavery as described by Dobson and Fisher?
Yes, very interesting question. Requires a bit of unpacking, Jason. Thank you for that. I think empowerment is crucial from a number of perspectives, one of which is to overcome, as you suggested, geoslavery, but it's, I think, one piece of the puzzle. So we are suggesting the empowerment of stakeholders, but sitting behind this process is, I guess, and I can point in the direction of some published work in this regard, is ideas around how we assume responsibility as technologists, as systems designers. So yes, empowerment is a critical way to overcome geoslavery, but there are other, I guess, responsibilities and stakeholders that have to come to the table to also contribute to that vision of overcoming socio-ethical challenges associated with location technologies, particularly as we get to the point where we have these IoT-based platforms with increased levels of connectivity. It becomes increasingly important. But yes, it is one element.
Thank you, Dr. Roba. With that, we come to an end of today's seminar series session. Thank you, Dr. Roba Abbas. It was a very intriguing, interesting, and eye-opening talk that you shared with us, and thank you for sharing your work with us. I've also received requests on a personal chat window with a request to have access to your paper. I'm sure it should be published, and the links we will share. And thank you for your time once again and for throwing light on this topic today.
Thank you, Professor Roba Abbas, for giving your time to us. It was an interesting talk. I think a lot of content that has been shared with respect to research aspects that you have discussed is excellent, of building theory, especially in the area which you are actually focusing on. And also you told about the application part for which was asked by Professor Santosh. I mean, that's really fantastic. Thanks for giving your time to us. Professor Yogesh couldn't join this session. He has sent a separate email for all participants who joined. He's traveling and hence he couldn't make it. And hence he is not here in this forum now. Thank you so much. I think the number of questions also were there, but due to paucity of time, it's almost, we have to close now, and hence we thought we can stop here. And I'm sure that all those who joined this session have immensely benefited from this talk of yours. I once again formally thank you for giving your time for this seminar series jointly hosted by Swansea University and SIBM Pune. Thank you.
Thank you. Thank you, Professor Raman, Professor Santosh. Thank you.
Thank you, Dr. Roba. Thank you, sir.